let's get started. So, first up, what is Linux? So, Linux, it's an operating system. Just like Windows is an operating system, just like Mac OS is an operating system. So, an operating system is essentially software that allows you to utilize the hardware in a more user friendly way. We're specifically going to be looking at what's called a shell. A shell, it's software that runs within an operating system. Sometimes it's built into the operating system, and it processes commands and outputs results. On Windows, there's something called a command line, and you may also hear the term terminal. These terms are generally used interchangeably, but there is actually a little bit of a difference. Command line is technically the space that you enter text. A terminal is essentially an interface that communicates with a shell. But for the purpose of this workshop, we're just going to basically use them interchangeably. There's a great link here for Geeks for Geeks. You can Google it up and it will explain some of the differences. On Linux, where are things stored? Things in Linux are generally stored in something that's called the root directory. The root directory, we're going to ignore different hard drive devices for now, but you can think of the root directory as the starting point, and it's signified by a forward slash. So when you see that forward slash and nothing else, that means you're in the root directory. That's where everything else branches off from. A directory, you can think of it as a box. And within the box, there are multiple boxes and maybe additional stacks of paper. And the paper might represent various files, and the boxes more directories. And you use directories sort of to organize how you navigate through where all of your files and software are stored. On Linux, there's a couple of directories that I view as more important for people knowing because they're the ones you're going to run into more often. The most important for everyone to know about is your home directory. So you navigate to that via the forward slash home, another forward slash, and then your username. And that's where all of your personal files are generally stored. There's a couple other directories that are important to have some awareness of. The /etc directory stores system configuration files. Lastly, the /deb folder and /media or /mnt folder. These are the locations where your devices are stored, /dev, and you mount those devices, and they're typically mounted so that you can read from like a file system in /media or /mnt, depending on your distribution of Linux. Okay, here's a visual example of the directory structure. So you have the root folder, and then within the root folder, you have additional folders like home. And then within the home folder, you have, for example, this directory here called Fred. Here is what it looks like when you look at it in a terminal. You don't have to worry about the commands for now. Just pwd shows the current directory that you're in, and then this tree-L1, which is one level, shows you all of the folders within or further down from the folder you're currently in. And yeah, so we're going to start going over how to use the shell. So the first thing that we're going to do in the shell is you can actually change what this portion here, the prompt, says. And the way you do that is through an environment variable called PS1. And what we're going to do is we want to change this to always show the directory. Oh, okay. Thank you for catching that. Big help. We always want to see the current directory we're in. This is just for convenience. You don't have to do that. There's a whole bunch of different ways you configure it. You can type in random text too if you wanted it to be that. So if you look at the prompt after I pressed enter, you have a tilde and then the $sign. The tilde represents that you're in your home directory. It's a It's just to be more concise. And everything after the $sign is things that you enter in. We're going to type in PWD, and PWD shows you the full print working directory. It means print working directory. So that's where we are in the system. The next command we're going to enter in is ls. ls stands for list. I've just typed in ls. Now we see all of the folders and files that are within the directory. It's handy to know some of the ls options. I like using LAH. You can think of it as almost like laugh. You hit enter, and it gives you a printout of the permissions, links, owner and group, size of the file, when it was made, and the name of the file itself. It also shows you hidden files. So in Linux, you can hide files by having a period in front of the file. The next thing we're going to try, actually, I'm going to show you this. You can type in clear and clear away everything from your terminal. Next, we're going to create a file. The way you create a file is you type in touch and then file names like files to copy. So hopefully you've made a file now. Now we're going to make a directory. So this is a folder within the file system. So mkdir, and then we're going to name this blah. Now we have a directory. It's useful for scripts. If you type in mkdir-p, the p option will mkdir. Oh, I missed the name. mk-p, we're going to name it blah. So what happens is when you type in a name that's already there when you're creating a directory, it will throw an error. If you're writing scripts, sometimes it's useful just to have it fail silently. The directory exists, and you don't have to worry about it throwing an error. To change a directory, first we're going to look at where we are. So print working directory, home/Fred. Then we will cd blah. CD stands for change directory. And we are now in the blah folder. You can type in ls, and it shows you there's nothing there. So let's try making a file. So touch, new file, and ls again, and we see there's now a new file there. You can see the file type by typing in file and then the file name, so new. And as a shortcut, if you hit tab, it will autocomplete. So new file is empty. There's a file there, and its type is it's just empty. If you want to get back, so you go back towards the root of the tree, the file structure where you're at, you can type in cd and then .. and you will go back one level. So if we type in print working directory, we're now back in home/Fred. To move a file, let's try and make a new file. So touch, and we're going to call this hi_file2. Now we're going to move that file by typing in move hi_file2, and we're going to move it to the blah directory. Hit enter. You don't see anything happen, but it did move. The key thing to remember is if the folder exists, so blah, that last portion of the command, if the folder exists, it'll move the file. If the folder does not exist, it will rename the file. If I create a new file, we'll call it new, and then we try and move it. We try and move new to the folder not exist. I probably spelled that wrong. And then we take a look. You'll see that we now have a new file here called not exists, and it didn't move. Next, we're going to try printing to screen. So echo hello there. And the echo command, it's pretty self-explanatory. It literally means echo. This is more useful than you might think when you're writing scripts or even doing command injection. This command will come up again. Okay, next up, we're going to move into the blah folder, and we are going to echo. We're going to say hello there, and then we're going to use two caret signs, so the right arrow slash greater than, and then we're going to send it to hi file 2. What this is doing is it's taking the output of the echo command, which will be the text hello there, and it's appending it into hi file 2. To view the contents of that file, we use the command cat. Cat stands for concatenate. It's a little bit dated, but you can concatenate the contents to display on the shell. We do hi file 2, and we can now see that there's a hello there in the my file 2, which also, if you type in file and check what's in the what type of file the hi file is, it will now say ASCII text. So it's now a text file. So we're going to create another file. We'll say this is the new 2 file. It's really not, but that's what we're going to say. And we're going to use one arrow, which means overwrite. So if it's not existing, it'll create. If it does exist, it will erase it and put whatever you're putting into it new. And we'll call it new 2. Okay, now we have a new 2 file. To merge the hi file to the new 2 file, we'll enter in cat hi underscore file. We'll use the 2 arrows, the greater than signs, and we'll do new 2. What this means is no such file. Oh, okay, hi file 2. There we go. What this means is that we're going to output the results of the hi file, and we're going to pipe that to append into the new 2 file. And now if we view what's in the new 2 file by typing in cat new 2, we'll see that it has 2 lines. This is the new 2 file, and now the contents of hi file 2, which is hello there. So you can pipe contents from one command into another. What we're going to do here is we're going to echo, and we're going to put a bunch of stuff into the hi file. So hi file 2, echo, we're going to add a hi. We're going to append it to hi file 2. Hi, let's add another hi in there. Hi file 2, echo, another hi into hi file 2. The semicolon is telling the shell to end the current command. We're going to add another hello, echo, hello, and we're going to pipe it into hi file 2. Okay, so now we've put a bunch of stuff into the hi file 2. So let's check that hi file 2. You see it says blah, hi, hi, hello. You can take the contents of hi file 2. So in this case, we are catting using the cat command, and we're using the straight line, which on my keyboard is just underneath backspace. And then we're going to put it into the awk command. So to be really quick going over awk, basically what the awk command here is doing is it's looking for the first set of characters in whatever it's getting. And so everything's one line. So we see per line, we see the first thing that shows up. So blah, hi, hi, hello. If there was a sentence in there, it would not show the entire sentence. Let's add some more text to the hi file. So echo, and we're going to say, hi there, Noid, and Howard, our old secretary. And we're going to put that in the hi file 2. And let's add another message. I don't know what we should say. We'll say this is the NSD. And we'll also put that in the hi file 2. Now we're going to go over the sort command. So what sort does is it goes through and it will order all of the contents of the file and output it. And so it looks like we have blah, hello, hi, hi, hi there. This is the NSD. This is actually a really useful command, especially if you're sorting through logs. You can sort unique using the -u option, which will get rid of duplicates. So instead of having two highs here, we now have one. This is super useful for finding, say, you're going through IP addresses and identifying just the unique IP addresses in a log. You can search through files by using the grep command. So I'm going to show two ways of doing this. First, we're going to cat the contents of hi file2, and then we're going to grep the word hi. And all the lines that have that pattern in it show up. You can also use the grep command by typing in grep, the pattern that you want, in this case hi, and then the file that you want to grep through. You can use ink sensitive search for case by using the -i option with grep. There are a whole bunch more options with grep. I suggest Googling through them if you need to do something more advanced. Another useful one that comes up is grep-i-v, and then we're going to type in b. I don't know if there's a line with a b in it. Let's choose t. What this will do is it's going to look through, ignoring case, and it's going to only output lines that don't match the pattern. And it outputted all of the lines without the T in there. This is useful for narrowing things down. Super useful. Counting. To count words, lines, and total characters in a file, you can use the WC command. It stands for word count. Type in hi file2. The first number is words, the second is lines, and the last is total characters. If you only want to count, for example, lines, you can do WC-L and then the file name. To view only the beginning of a file, you can type in head -n, the number of lines you want to see, which in this case is 2, hi file2, and it will show you the first two. To see only the end lines in a file, you can use tail -n, just like head. We're going to look for the last two lines, and we'll see what the last two lines in the hi file is. We're going to move on now to how do you run a script. So first we need to make a basic script. So I'm going to type in echo, and I hope echo works in Debian the same way it does work in Fedora. And we're going to give it we're going to echo the ls command and then grepping for hi, and we're going to name it script.sh. Okay, if you type in ls, script.sh should show up. We're going to double check that it wrote in there correctly, and it did not. So I'm going to edit that really quick. Vim script. We're going to go to the very end, and it's easier when this is right in front of me. Right, and then quit. Okay. I probably typed something in wrong. The first way you can run a script is by typing in bash, assuming your shell is bash, which on most systems it is. And then you hit enter, and it ran the echo command. In this case, it outputted hi file2. The other way that you can run a script is // and then the script name. And we ran into a permissions error. Two ways of running it. Keep the bash command in mind if you run into a permissions error. But if we move on to permissions, I think I'm going to share. For permissions, you can see permissions by typing in ls-lah or -a should be sufficient, or -l should also be sufficient. Permissions consist of 4 parts. So that section where the dash is and R, W, there's a D there and an X, that's the permissions. The first dash or character means, is it a file or is it a directory? If it's a dash, it's a file. If it has a D, it's a directory. The next 3 characters stand for the owner permissions. The next 3 after that stand for the group permissions. So a file can be added to a group, and it will allow everyone in that group to access the file according to the permissions that have been given. And then the last three is for users, just all users. You can change permission settings by using the chmod command, chmod, so change modifications, I'm guessing. Some of the common permission settings include 777, which is full access. It's also insecure. 700, which is owner has full access, everyone else doesn't. 444, it creates read-only access, and 755 means owner has all access, group and users can only read and execute. Two less common but kind of useful is 555, read, execute only, and 644, owner and group read, write permissions. Okay, that may seem a little bit complicated. Each of the places in those numbers gives a permission for either owner, group, or users. And the number corresponds to this little chart over here for the permissions. So in Octal, a 0 is represented in binary as a 000, and that sets all permissions to no access. If you look here, a 1 means execute, a 2 means write privileges, a 3 means write execute, a 4 means read, a 5 means read execute, a 6 means write read access, and a 7 means write read and execute. So each number here corresponds to one set of 3 over here that you can see. There are other ways of setting permissions, but this is the way I do it, so this is the way I'm explaining it. You can Google that if you have issues. If the chmod command doesn't work, try typing in sudo. It'll ask you for a username and password, and then try setting the permissions. We'll keep moving forward. Okay, so let's now show what the current running processes are. So in order to do that, I'm going to clear. You can type in PS. It will show you what's running under your user. You can also type in PS-E, I believe, and it will now show you all the processes for the system. As you see here, it's not showing the bash shell. EF, I think the other one. There we go. Type in PS-EF, and I don't remember what that is, but it shows you everything. So we have a bash shell here, and what we're going to do next is we're actually going to try and kill it, which means shut it down. So if you have something that's running and it's not stopping, you can kill it by typing in kill and then this number over here, which should be its PID number. Let me double check I'm getting that right. Yes, it's in the first column. So in this case, 15933. For me, it'll be different for you. Okay, it's saying no such process, but obviously, oh, that's not the bash shell. Well, if it was the bash shell, it would then try and shut it down. It doesn't always work. If you type in man for a command, it will take you to the manual. In this case, we're going to go man kill, and it will have a whole list of instructions for things. You can type Q to exit from that. You can also go kill -L, and it will list the various different kill signals you can send. So kill -64 process PID, some random number. There are some that are more aggressive than others. Sometimes it's useful to identify your CPU. You can do this by typing in cat/proc/CPU info. And on most Linux systems, it will tell you what is currently inside the computer. If you want to have a nicer way of viewing files, you can use the less command. Less is more. They teach more here at CSUMB, but less is actually better. You can scroll up and down. It shows you all the contents of the file. You can use, I think, HJKL to scroll up and down, or arrow keys. Type Q to exit. There are some other editors like Nano. Nano is a popular one on most systems now. You'll see the stuff on the bottom is the links that you can use. So in this case, the caret X stands for hitting Control X, and it'll allow you to exit. To see past commands, you can type in history. To see total disk space, you can type in DF. In this case, generally you want to look for the root directory, which is here. It's not in a nice easy line for you to see. And it gives you a bunch of numbers that's probably in bits. There are options to change that into a more human readable form. You can type in man df to view the instruction manual to see how to do that. Dash H is human readable. You can find commands on a system by typing in which. So for example, which echo, and it will return the directory that the command is in. And we're almost done here. We got 3 more slides. If you want to download a file from the internet, you can use the wget command. So wget, in this case, we're going to see what Google gives us. www.google.com. And in this case, it downloaded a file called index.html, which is actually the Google main page. Google obfuscates it, so it's really messy. So if you take a look at that, we'll type in less index.html, and you will see a bunch of gobbledygook. Yep. wget is actually really useful, even if you're just downloading files, especially large files, because if your connection is interrupted or if there's an error, you can run the wget command again, and it will resume where you left off, rather than what a lot of web browsers do, which is force you to re-download the file anytime there's a little error. I don't know why web browsers aren't better. So use the wget command. Okay, and for these last 2, these show up a lot in workplaces. The SSH command. The SSH command is to log into a remote system. So SSH, your username, and then at an IP address, or it could be a URL for the system that you're accessing. However, if you're using SSH and your connection goes down, everything that you were running will stop. If you're doing something and your connection goes out, you don't want it to stop. I highly recommend learning the screen command. So you log in via SSH, and then you type in screen -s, and then name the session. When you disconnect, you can reconnect via SSH. You type in screens or screen-ls. It will show you a list of the various screens that are available. And then you can type in screen-xs and the name of the session to resume whatever you were doing before. So if you're running an analysis on a large file, compiling something, you're going to want to use a screen session, because if it accidentally goes down, even for a few seconds, it's all over. That is everything. Thank you. So this was a quick overview of a lot of the basic Linux commands, and knowing this much should be sufficient to now take part in at least 50% of all this NCL activities. Are there any questions? Okay, thank you.
Thank you so much, Tim, for an amazing presentation. I learned a lot about the Linux terminals and the commands. Thank you so much.